Welcome again to Night Owl Cinema and Online DVD Rental. In this video we want to show you our implementations for tasks 7, 8 and 9. At first, we want to show you our approach to enrich our data with generated values and data fetched via an external web service. After that, we will present you our Night Owl web interface. And at the end of this video, we will show you our approach of using Google Fusion tables to visualize interesting insights into our data. So, let's start with the enrichment of our data. The schema that is about to be populated can be roughly subdivided in 3 regions. The movie meta information, such as language, extras, directly related details, and disk separation. The wishlist information, so customer, order, and item. The cinema-related information, which are screening, cinema hall, seat, screening type, and tickets. And finally, the uniting entity movie version. To further populate this schema, 2 external data sources were used. On one hand, we had 3 CSV files, which were filled with respective male and female first names and last names. On the other hand, we used the web service called the moviedb.org. The MovieDB offers various information on movies. A standard query contains the information listed on this slide. For example, whether it's rated for adults, which genre it can be accounted to, the spoken languages, and many more. The aforementioned data was used to improve the database. The random generation of new data as well as the data gathering from our sources was done in a C# application using the .NET framework. To generate classes suited to the API's output, we made use of the service JSON to C#. Further, the library JSON.NET enabled us to deserialize the API's answer into the fitting instance of that class. The information gathering takes place as follows. First, an initial query on the movie list is executed to detect the number of available movies and the number of result pages of the API request. After retrieving these numbers, we call the method movie@index to get the movie at a specific index of the movie list. In this method, we have to query the movie list again, but we will now specify the page numbers corresponding to the movie index. With this result, we will get the ID of the movie, which will be used to finally get all movie information from the API. For each of the retrieved movies, its existence is checked in our database by looking up its title and its IMDb ID. In case that it is not yet in our database, the movie's information is stored. If the information contains one or more translations, one of them is chosen randomly as the dubbing language. For each language, its existence is checked. If it does not yet exist yet, the language is created. All of the listed languages are then associated to the movie. For all tables that were not covered by our external sources, random data was generated. 7 generators were set up, which allowed us to control the generation and collection parameters for both random and external data. As mentioned before, movie information is retrieved from the moviedb.org. It is possible to choose the movie list that should be used, whether the movie should be in order or randomly sorted, and the amount of movies that are collected. Customers are generated by combining first and last names from the CSV files. Again, the amount of entries can be chosen. The cinema generator and all of the following generators populate their tables with synthesized data. Here, the amount of halls can be specified, as well as ranges for the seats and rows and the ratio of seat classes. The copies generator generates an overall amount of copies that is then distributed over all movie versions in chunks of specified size range. A specified amount of screenings can be generated. As boundaries, a time span can be given, as well as a movie version ID range and a number of different cinema halls they can take place in. Furthermore, the ratio of special movie nights can be chosen. The ticket generator creates an arbitrary amount of book tickets limited to a number of randomly chosen screenings. The ticket's price range can be specified, including discounts for different seat classes. Finally, the wishes can be populated. Despite the amount of wishes, a number of randomly chosen customers and a date range can be set. Also, ratios of sent and returned copies can be specified. The movie generator affects 4 tables: movie, movie version, language, and the movie version language association. As one might expect, the customers generator only alters the customer table. The Cinema Hall generator adds entries to both Cinema Halls table and Seats table. Just like the Customers generator, the Copies generator only affects one table, the Copies table. The Screenings generator enhances the Screenings table as well as the Special Movie Nights table. The Ticket generator solely alters the Tickets table, and finally the Wishes generator updates the Orders and Items tables. Now that the data has been enriched, it is time to actually use the data. Since the members of the executive board are not experienced in neither SQL nor any programming language, an easy-to-use web interface is the access method of choice. This web interface was implemented in Ruby using both Rails and Twitter Bootstrap frameworks. To have meaningful information at hand, we made use of sophisticated queries which allow to link relevant data before further use. As our time is limited, the following single query for the movie detail page should be seen as an example. Despite the directly assigned information, the query also includes joint subqueries for the number of rentals, the number of available copies, and the amount of cinema visitors. Further, it features a list of both the available extras and languages the movie comes with. Using similar queries, central information views are fed with data. The dashboard, for example, offers a quick overview over the most important information: the most rented movies, the most profitable customers, and the overall most lucrative movies, which take both cinema and DVD rentals into account. The customers list gives an overview over all registered customers, including an option to see all rented movies and their respective return statuses. Looking at this Cinema Hall overview, one can easily notice that it was designed to allow a fast glance on the featured screenings. Finally, there is a view for the movies that are stored in the database. Clicking on one of the titles takes you to the detail page of the selected movie, which features information on that movie. This information is aggregated from the database as well as from the online movie database. Despite some meta information on the movie, it also features the current screening times and stats for the movie and its associated versions. If one clicks a screening time, an overview of the current seat booking for that specific screening is shown. After we got an overview over the enriched schema and the web interface, we now come to the visualization of the data. To generate visualizations in an easy and fast way, Google Fusion Tables was used. At first, we made a visualization of the geographical location of our customer addresses. As the addresses in our mediated schema were randomly created, non-existing addresses from a previous task, they were not suitable for geo-coordinating. Therefore, we used random addresses from an external address book to build a CSV file containing all customer IDs and one address assigned to each customer ID. From our mediated schema, we extracted all customers with their IDs and the amount of their rentals throughout the whole time. The resulting CSV file was imported to GFT and within GFT merged with the previously created CSV address file. The resulting Fusion table could be used to create a geographical visualization. The image on the left shows the unweighted distribution of our customers, while the image on the right shows the distribution of our customers weighted by their amount of rentals. Differences can be found, for example, in Stockholm and Helsinki, as well as in South Italy. Some of our top customers seem to live in those two regions. The next visualization shows which screening times our cinema visitors prefer. We splitted all presentation times into 3 blocks: afternoon till 6 p.m., evening from 6 p.m. to 9 p.m., and late night after 9 p.m. For each block, we counted the number of sold tickets. The result shows that the afternoon screenings are the most visited, which may, for example, be an indicator to set up more family screenings in the future. Another question we want to answer is in which relation the number of copies of our DVDs are to the number of rentals of their respective movies. First, we simply want to load the plain number of rentals and copies. Therefore, we join the movie version table with the item table and the copy table. After that, we join a query that calculates the ratio we are looking for by, again, using the item and copy table to fetch its information. Visualizing the data, we created 2 bar charts. First, a top 20 list of movies with the best proportion of rentals per copy, led by the movie Death at a Funeral with a value of 1.2. And a flop 20 list that indicates movies where we may have too much copies of, and so get a small value like Night at the Museum with only 0.1 rentals per copy. To get an overview of the utilization of the cinema, we created a visualization of the amount of available seats and the amount of booked seats for each movie. Dividing those two numbers gives us the utilization for each movie whereby all screenings are considered. These results are visualized by a column plot. The blue and red columns represent the available and booked seats for each movie and refer to the scale on the left side of the plot. The yellow columns represent the utilization and refer to the scale on the right side of the plot. As one can easily see, the movie Il mio nome nessuno, also known as My Name is Nobody, did not meet our expectation of visitors. The movie was screened 2 times in our biggest cinema halls, resulting in 732 available tickets, of which only 68 could be sold. One more interesting question is, what are the top rented movies among different customer groups? The customer groups we would like to get hands on are characterized by age or gender. During the following query, we will show you the observed customer groups. Our query consists of 6 subqueries, each for one customer group. The first left joined subquery asks for all customers who are younger than 25 years. Our second subquery displays all customers that are between 25 and 40 years old. The next interesting age group that we query for is the one containing all customers that are older than 40 but younger than 65 years. And the last customer group that is characterized by age contains all customers who are older than 65 years. Next to the age characterization, it would be interesting to see the difference between the top movies rented by women or men. Therefore, our fifth subquery selects all female customers, where our last subquery collects only male customers. We display our results via bar charts to get a fast overview of the top movies. As we have 6 customer groups, we need 6 charts for each customer group to display our results. Here, we do not show each chart, just one exemplary chart for the 2 different characterization types, age and gender. The bar chart of the age group over 65 years displays the movie Prisoners, Safe House, Hellboy 2 and Snake Eyes as the top rented movies with 6 rentals each. The top rented movie among our female customers is the movie Start of Something. So, this was our short presentation on how we implemented tasks 7, 8 and 9. Thank you for your attention.